Okay, guys, so this is chapter 5, section 1, part 2. So last time we talked about creating scientific notation, and I should have talked about going in reverse. So I'm going to talk about that here in a little bit in a second. But remember your rules. So all numbers must be between 1 and just less than 10. All exponents on the 10 must be whole numbers. The exponent on the 10 is equal to the number of places that you move the decimal to satisfy rule number 1. And then rule number 4, if the original number is between 1 and 0, the exponent will be negative. Otherwise, it is going to be positive. So big numbers are going to have positive exponents, small numbers are going to have negative exponents. And then we practiced those ones. But before we get into the real part 2, I just want to review what it would be like to go in reverse with these. So let's forget about these ones for a second. So we're not going to talk about those. What if we had 1.73 times 10 to the third? So if we want to go in reverse, think, okay, because it's a positive exponent, this number was big to start with. So we're going to move the exponent to the right 3 places. So 1, 2, 3. So we're going to have 1730 will be our answer. Okay. Again, if we had 3.4 times 10 to the 5th, again, because this is a positive number, we are going to need to make this a big number. So we're going to move it 5 places. So 1 and then 4 zeros. We'll add our commas here. So 340,000. And then if we had a really small number, so if it was 1.3 times 10 to the negative 3, now we know because this is a negative number, we need a really small base number here. So we're going to move it 3 to the left. 1, 2, 3. So we're going to have 0.0013 as our answer. And then let's do one more. If we had 5.67 times 10 to the negative 4th, again, because it's negative, we know that this number was originally smaller, so we're going to move it 4 places. Should always have a 0 placeholder here. So we'd move it over, add 3 zeros, and you can always check your work. If you're confident doing it one way, we'll check your work. So if we move this 1, 2, 3, 4 places, we'd end up with 5.67 times 10 to the negative 4. Okay, so you can flip-flop back between those pretty easy. Okay, so I just wanted to review that in case you were struggling on that, or if it was hard to go that direction. I should have done it in the first video, and I apologize. But here you go. Here's some examples for that type. Okay, and now we're really going to get into how we're going to use those. So whether or not you can go back and forth is important, but the main focus of this video is going to be adding and subtracting, multiplication, and division of scientific notation, so numbers that are in scientific notation. So when we're adding or subtracting, this is actually the more difficult part to do, because the power of 10 in each term must equal one another. So we may need to move some things around to make these exponents the same. Here in this example, it's not a super good example because they already are matching, but once you have them matching, you just add the whole numbers and then make sure it's back in scientific notation here, and then make sure it has the correct exponent there. Multiplication is pretty easy. So all you're doing is multiplying both whole numbers and then adding the exponents. And division is also pretty easy. So you're going to divide the two numbers that you're given, and then you're just going to subtract the exponents. Okay, and we're going to practice some example problems of each. Okay, so remember, when we're adding and subtracting, exponents need to match, and you're gonna move the decimal place to make them match. Then you can add them, and then you keep that exponent that was matched. Multiplication, you're just going to multiply, add the exponents. Division, you're going to divide, subtract the exponents. Okay, so not too bad. You just got to keep it straight which time you use which method. Okay, so let's see. All right, so we're going to start off with addition and subtraction. Let me get my pen here. Okay, so 4.5 times 10 to the fourth plus 1.75 times 10 to the fourth. Because these are already matching, we are good to go. So we just need to add 4.5 plus 1.75. Okay, and we are going to get I think it should be 5.25. Let me check. Oops, my bad. We need to 6.5. I forgot it was 1.75. Okay, so 6.25. And then we're just going to keep that exponent, so it's going to be times 10 to the fourth. Okay, but let's say, for example, let's erase this and let's do this again. So when they're matching, pretty easy, just a regular addition problem. But let's make this one a 3. So nothing else is changing. We're just going to make this one a 3. We cannot just add these two because these exponents do not match. So we have to make them match. And you could do it one of two ways. You could move this one to make it a 3, or you could move this one to make it a 4. Make this exponent a 4. I'm going to do it both ways for you. The first way we're going to do is we're going to make this one a 4. So again, like what I explained at the beginning of the video, we know that since this one is a positive number, that this was originally bigger. So if we want to make this exponent a 4, we're going to move it one more place. Okay, so then we're going to have 4.5 times 10 to the fourth plus 0.175 times 10 to the fourth. Okay, and again, if I was thinking about making this a really big number, if this was a really big number, to move it one more place would make that exponent a 4. Okay, then we add those together, and that gives us 4.675 times 10 to the fourth, and we're going to keep that fourth place. Okay, we're going to take the same problem and we're going to do it another way. So this time we're going to make this 4 a 3. Okay, to make it smaller, we're going to move it to the right. So we're going to have 45 times 10 to the third plus 1.75 times 10 to the third. Okay, when we add those ones together, we're going to get 46.75 times 10 to the third. Now, what's wrong with this answer here is that it's not in correct scientific notation. So what we need to do is get it so that it is. And that's going to take moving that decimal place one place to the left, and we're going to get 4.675 times 10 to the fourth. And you can see that no matter which way you do it, your answers are exactly the same. Okay, so you should end up with the same answer both ways. Another way to think about when you're moving these decimal places, and if you're fine moving them, then great. I don't want to confuse you. You could probably just ignore this sentence. But when you are making your decimal place bigger, your exponent gets smaller. So when we made this exponent smaller, our number got bigger. Instead of 4.5, it became 45. And then the opposite here, when we want our exponent to get, so when we change it, this one, when we want our exponent to get bigger, so when we wanted to make this a 4 instead of a 3, our number became smaller. So it's the opposite. If you want your number to get bigger, your exponent gets smaller. And if you want your number to get smaller, your exponent gets bigger, and vice versa, if that makes sense. If you're good with just moving it and keeping track of it that way, that's fine. If not, that was another way to remember it. Okay, so let's go ahead and look at this subtraction one. Subtraction is done the same way as addition, so we do have to make these the same. I'm going to go ahead and we'll do them both ways again. We'll start by making this one an 8 though. So when we want this number to get bigger, our exponent or our number gets smaller. So if our exponent becomes bigger, our number is going to get smaller by the same number of places that this moves. So we're going to have 8.87 times 10 to the 8th minus 0.93 times 10 to the 8th. Now, because our exponents are matching, we can just go ahead and do the math here, and we're going to end up with 7.49 times 10 to the 8th. Okay, so we just use that number, carried down our exponent. And just for the sake of time, I'm not going to do it the other way. If you can kind of think out which way it's going to add or subtract easier, you could do it that way too. This one would obviously be an easier subtraction problem than making this one a 7. This one would be 88.7 minus 9.3, and then you'd subtract that and you'd end up with the same thing. Okay. All right, if you have any questions on that, make sure you let me know. Okay, now remember for multiplication and division, it's a little bit easier. When we're multiplying, we just add the exponents. When we're dividing, we subtract the exponents, and then we would do everything else the same way that we would. Okay, so this first one is a multiplication problem. And the first thing I want you to notice here is just pay attention. Is this in the correct scientific notation? No, because we don't have a whole number to the left of the decimal place. For this case, it's going to be fine because we can, if it doesn't turn out right, we can just put it in scientific notation at the end. So don't bother fixing it now. So what we're going to do is we're going to take 0.8 times 1.28, and then we're going to have 4 plus 6 as the exponents. Or you should really have times 10, so the whatever. But we're just going to take this 0.8 times 1.28, and we're going to get 1.024 times 10 to the 4 plus 6. That would be a better format. I should have written this one like that up there. Okay. And then just to finish this, we're going to have 1.024 times 10 to the 9th. Okay. Oops, not 9, 10. 6 plus 4 is 10. So times 10 to the 10th. Okay, so pretty simple. And let's do a division one here. So we're really going to take 7.8 divided by 8. And that's going to give us, if I plugged it into a calculator, is going to give us 0.975. And then times 10 to the, remember this time we're subtracting 4 minus 1. So we're going to end up with 0.975 times 10 to the 3rd. And again, if I wanted your answer in correct scientific notation, this answer would be incorrect. Why? Because we don't have a whole number that is in front of that decimal place. So we're going to go ahead and we're going to move it over, and we're going to have 9.75 times 10 to the what? If we move this over one place and we're already at a 3, we're making this number bigger, which is making our exponent smaller. Okay. All right, and that's all I have for you. So now you're going to work on some practice problems through Edpuzzle. So good luck. Make sure you reach out to me if you have any questions or are confused on any of the concepts. Okay, have a great day. We'll talk to you later. Bye, guys.